Okay. If the uncertainty in its momentum is reduced to 0.01%, what uncertainty in its location must be tolerated? So it's definitely one of those. It's definitely one of those Heisenberg uncertainty problems, right? They're talking about uncertainty. So here it is right here. Delta P times delta Q is greater than or equal to h bar over 2. Okay. And I think the only trick to this, and once you see it once, it's not so bad. When they say the speed of a proton, okay, here, this part, 0.01%. Right? The uncertainty in the momentum is 0.01%. So when they're talking about uncertainty, I wish they would use all the words, right? Because if you want to get uncertainty in something, you have to take the variance or the standard deviation and then divide it by what the value is. Otherwise, it's not really uncertainty. It's just variation. So when they say 0.01%, that is really 0.01%, right? The uncertainty over it divided by the value, because they gave it in percent. And that, to me, is the trick to the question. I guess the other trick to the question is, how do you get rid of a percent? You move the decimal place over how many places to get rid of it? 2. So it's not 0.01, it should be 0.0001. So that value, delta P over P, is really 0.0001. So then you just kind of do some algebra and see if you can plug and chug and figure this out. Okay, so if we want delta P over P, because we want to put in this number for it, number for that, so we'd have to divide through by P. All right. And you remember P is what from the concept preview? What's P? Momentum. And it was what times what? Mass times velocity or speed. So P is really mv. And that's why I guess I'm comfortable dividing both sides by P. It seems like I introduced a whole new variable, but I didn't. First, this part we said was 0.0001, right? Then that P was just m times v, but they told us the v part. I don't know if you've gotten used to this author yet, but how do you know what m is? Right? Because that P is supposed to be m times v.
You gotta look it up.
You gotta look it up. Yeah, they're gonna do that a lot to you. So you're gonna end up with 0. Oh, he's locked up. 0.0001 delta Q greater than or equal to h bar over 2 m times v. And like Ricky said, look this guy up. How about h bar? Again, the cheat sheet, the equation sheet, right?
1.05.
Yeah, you plug in that times 10 to the negative whatever. And you know what v is? Right? There. So just solve for delta Q and you're done. Okay, so that's kind of the game that we're playing. Then you just get a number. Okay. So we have a ground state wave function for a particle combined to a one-dimensional box. And here's the length. Okay. Use the wave function above and write a general expression to determine the probability of finding a particle between x equals a and x equals b in a one-dimensional box of length L. Okay. Before we jump into that, why does it say D? Did I skip some questions? I just want to check something quick here. I don't think so. Nah, I don't have them typed up here. No. I just screwed up with the letters. Okay, before we jump in there, let's go back to, I think yours is right though, isn't it? B, C, D. I want to make an A. Is psi normalized? So this is getting into that terminology. All right, get used to it. Is psi normalized? That's all the questions on the exam. What would you do? Is psi normalized? Yeah. Is it normalized?
Looks like it, because I think the square root tends to be the n.
Yeah. Yeah. So yeah, I agree with you totally. And you also have something out in front of the sign. Usually that's your normalization constant. That's your n, and it's just got the square root thing. But you can't just say it looks like it. You got to. I guess the better word would be say show, but I kind of like the more the conceptual way of asking questions. I mean, you can say, yeah, it looks like, but you got to show it. You got to prove your answer. How would you prove it?
You can take your sine pi x over L and then multiply it by, you'd solve it using that as your function, your wave function.
Okay, now good. What's the starting point? What's the starting point for the it that you're talking about?
So your wave function is sine pi x.
Yeah, I know, but what I'm trying to get at that one equation that you write that guides all your efforts.
Oh, something equals n times normalized wave function times regular wave function.
Yeah. You see what I'm driving at here? You're clearly really close. You could start where you're saying, but you're missing some parts and the little details.
N equals n
What's the equation for the normalization equation? The starting point. 1 equals. Yeah, kind of. But what did we say?
Integration.
The integral. There we go. I wanted that integral in there. The integral of what?
of the wave function normalized times the wave function. Isn't it sine?
Yeah. So you could. This is really what I was after. But if you're, and what Brad was talking about is, that n phi, which if you want to memorize it that way, fine. But to me, this is my starting point. I mean, I think Brad was also talking about n phi. But notice how this is getting much more complicated. You better have a star in there. So I like it. This is my starting point. And then how did I define the normalized wave function? I called psi what times what?
N times phi.
N times phi. Okay, so when it says show is psi normalized, where do you start?
You just pick your phi here and make it sine pi x over L.
Do you start up here or do you start with this one? What is your, are you going to call?
I would start up there.
What equation would you write, put it that way, to get this going?
Phi equals n phi.
I'll write sine of no. What are you doing?
I guess use the notation. The reason why this is my starting point is because I'm really used to using the notation. And that psi, they said is, I don't care what it is, I mean, is something normalized. I put it in right here. Is this normalized? Because this is the normal, I just stick it in right here, star, and then multiply it by itself again. They could ask anything. Is anything normalized? So you don't put it in an n or anything. All you're doing is something normalized? Put it in the normalization expression. And if you don't get 1, it's not normalized. That make sense? So that to me would be the starting point. Psi star psi. So put in the 2 over L square root sine pi x over L times, same thing again, and you'll end up with 1. So you could pull the 2 over L out because you're just multiplying it by itself. What's that?
Also unsquared or?
Is it right? They want to know if something's normalized.
Oh.
So all you do is whatever they're asking about, you put it in for that something. Is this normalized? Just put it in for that. And you can write a question mark over the 1, I guess. Right? Do you get 1? And then what we didn't really talk about are what are these limits going to be? We didn't really specify that. What are those limits in this general expression?
Since it's a sine function, what between 0 and pi?
Right?
The limits. Oh, it should be a.
For part B, yeah, it'll be A and B. But I'm talking about, is this guy normalized? So whenever we substituted into this normalization expression, what did we put in here for limits?
0 to L.
Yeah, it's really over all space. Negative infinity to positive infinity, but it's 0 outside the box. It has to be between 0 and L. So that really came down to just being 0 and L. But it's really over all space. But it's 0 outside the box. That doesn't do much good. So just between 0 and L. And what is the, now I wrote this for you, I probably shouldn't have. How did I know to write dx instead of,
D tau?
yeah, how did I replace d tau with dx?
Because it says to a one-dimensional box.
It says one-dimensional box. And what is the dimension? It's x. Kind of got to read further down. Well, you know, you can look in the equation. There's your one dimension. There's x. Okay. So you can, I don't know, we can, do you want to finish that here, or do you want to go on to the next one?
Go on.
I think we've done this one, that integral before,
Yeah.
right? Okay, so let's go ahead and, so I think the hardest part in these is just setting these up, right? The hardest part is setting these up. And I think that equation sheet is the way to have it next to you, because at least that's what I'm used to looking at. Mm-hmm. Yeah.
What is?
The equation sheet. So set up the next one. Set up part B. If you want to work out part A, go ahead. I'll be glad to help you out with it.
What was that one easy, I forgot already.
What, that one?
An identity? Yeah.
Oh, it's 1 minus cosine 2x over 2. It's 1 minus. So for that one, you would put 1 minus cosine 2 pi x over L.
Yeah. You talk about it's cosine.
There it is. See? Copy you made me?
Oh, okay. Yeah. So for that one, yeah, you need more copies?
No, we're good.
1 minus cosine 2
Yeah. So you should have this guy.
Yeah, I have mine. Okay.
Are we obligated to bring our own?
No, I'll give it to you.
Okay.
And then you would put the half out. So
No, I have
bring
mine.
the
It's
half
at
out
the-
front.
Oh,
And
okay.
then you cancel that 2. See between the L.
Right.
Yeah. Cancel it 2. And you just need
Not right hand
over
over
L on that.
It's because I had that one and then I had a separate one, but I
So it
lost
was a
the
super
separate
long
one.
one.
Yeah, you don't like it.
No, like that.
This one looks familiar.
Yeah, because we did it already.
Oh.
Except for the other one was cosine squared. Essentially, you should get
So you should break it up into two integrals, right? Okay, so which one did you want to work? You want to finish this one, or you want to go on to part B? Part B? Paul wants to go on to part B.
That's up to you guys.
Yeah, that's cool. Pablo feels confident.
Okay.
Want to do this one back?
I'm just kidding.
It doesn't matter. I'll practice with you.
Okay. Because you've had a good amount of practice doing these integrals. I say setting them up. So let's set up part B. All right? You have a one-dimensional box of length L. Set up the equation to get that probability.
Yeah, it came out to 180.
Okay.
Yeah. Not the way I remember it coming out to L either.
Part B. Okay. So
Don't worry, I will.
what's the general expression that I'm trying to get you to write at the very beginning for something like this part B?
The 1 equals the same expression.
Yeah, except we're going to change one thing.
The 0 to L is not going to be 8.
Good, that's going to be one thing. So we're going to change these limits, but we're also going to get rid of the 1 and just write the word probability. Because if you get 1, that means 100%.
And we also know since it's still one dimension that the d tau is going to be dx.
Yes, exactly. So I think what helps me with this stuff is when I see that type of probability question, this is the only thing I think of. It kind of gets rid of the ambiguity. This is the only thing I think of is probability equals this integral, where what Brad said, you put in the limits, because you can't get 1 anymore, because that's normalization. And that expression really isn't on here, right? It's just, it's the normalization expression, right? Right there, in the middle. But it's really probability equals the normalization expression.
Is there a symbol for probability?
Mm.
I'm sure it's not P.
Man, you think there would be, right? They use it so often.
Is in the homework and everything. That's
I've
one
never-
of the only words that I keep writing.
I've never seen one.
Huh. That's like,
And in there, we need to put the normalized wave function, or since we already, proved that it's normalized, we could just put it in.
Yeah. Well, and two, use the notation. The notation leaves it unquestioning. You have to put in your capital psi. Now, how do you get your capital psi? Or if you want to start at the very beginning, your capital psi was here, right? And then the next step was, oh, okay. Whoop, star goes there. Right? And then the next step is the probability. So when they say that psi is that psi, and that psi is that psi. So they're not ambiguous at all. They're all the same. So see if you can write that general expression and solve for it. Right? You want to get general expression for the probability.
So they just set from A to B?
Mm-hmm. A and B are your limits, little a and little b.
What was the? I didn't write it down. I thought it was
Square root 2 over L sine n pi x over L. Well, you're not going to have a 1 there. Yeah, you have to have A to B here.
But I don't know.
But it's going to be very similar.
I was saying, so we could have
Yeah.
taken like the integration part where we know that
The one, the,
2L, where we solve the wave function, we do wave function times wave function.
yeah.
We could just reapply that into B, right?
Well, yeah. In fact, what I could see you doing is write this expression, substitute it all in there, and then if the first part said, is it normalized? I mean, look at way down here, where you divide into 2 integrals and things. All that's identical. You could almost just as well just jump down, copy one of these, right, and save a lot of steps instead of doing it all over. But it's not really that much, but you could save some time. Did you get this far?
Is your lowercase n
Little n is going to be something that we really haven't got to yet, but it's just going to be another constant, and it's going to be a quantum number that's going to give us different energy levels. So for us right now, it's just a constant. And
should we have added that?
wasn't that? Oh, that wasn't in there.
No. Not in the
Oh,
original.
I added it in.
Yeah, you have.
Oh, whoops! That's not supposed to be there. I'm jumping ahead.
That's like,
Sorry. Yeah, that shouldn't be there. That will be there next chapter, I think. Sorry. So what did you write, Pablo, as your right here? Derivative of what will give you that cosine 2 pi x over L?
L over 2 pi.
Good.
Sine. Whatever's inside.
Exactly. I like how we said it, right? Doesn't matter what's inside. It's the sine of whatever's inside. Don't even think about it. You pretty much just flip it. And you can do the derivative of it to test it, to see if it works.
And this is on Wednesday.
Yeah.
Just out of curiosity.
You can come early.
Huh. Can't come early?
Yeah, you can start early if you like.
And what if there's bad weather?
Well, then there's no school.
So then will we assume then that it's automatic on Friday, or will we do it in lab on Thursday?
I worry about that one now, but odds are, what are the odds of there being no school again?
Actually,
Or even school being
Yeah,
late?
because there's another. It's supposed to be like last week.
Yeah,
I
but
saw the news this morning.
I know it's gonna be cold.
No, like I saw the radar. They have this pink stuff like all over San Antonio.
No way. I didn't want to get my hopes up.
I'll show you the work.
I don't even want to get my
Great
hopes up.
Great man told me last week, keep your positive thoughts.
It was so nice having Friday off.
Yeah, he said have your cold
And
positive.
you know what
thoughts.
sucked? Was having to come Saturday for that event. That sucked, man. Did you keep your shirt? You can't hear it. You can't hear it because I watched the video last night. You didn't hear us talking.
Really? Okay.
You hear Ricky.
It's
Ricky's
rare.
voice carries. Dang, man.
Yes. 1 million viewers are gonna go watch our PK lecture.
You can't really simplify it much more than this, can you?
No, that's what I meant.
Okay, then the next part was between 0 and 10 nanometers when L is 10 nanometers. You better get an answer of what for this? No, it's probability. The probability of it being between 0 and 10 nanometers when the box is 10 nanometers long. What should be the answer for probability?
Just be 100.
It better be 100. Well, in our case, not 100. It's going to be
One.
1. Right? Otherwise, we screwed up somewhere. So try it. So do you have to do the whole integral for this thing again? No, you just made this nice expression. Right? I would start here. I mean, you could do the whole, right? Yeah. So you can just leave that nm for nanometers off and just put in 10 for L and what, 0 for A and 10 for B. That's what I would do. This is part C. A would be 0, B would be 10, and L would be 10. And substitute.
See right here, sine squared pi the next step is doing the identity and bringing those half steps. And then you integrate this. You did get it.
Hopefully we get one. Otherwise you messed up somewhere.
Oh, time to go already?
You have 10 minutes.
Oh, let me see.
Oh, really? No, I don't, because I live in organic.
I need as much damn practice as I can get.
It's inorganic today?
Yeah.
Oh, you see, she tricked us.
Well, that's good, because then PChem you have more time.
Actually, I don't know.
She has it.
I asked her on Saturday in the morning,
Yeah,
and pretty much all she said was if there was room in the schedule, she would move.
yeah.
But if there wasn't,
So we don't.
I think this exam's pretty doable. I mean, if you've been doing all the homework on your own, not copying it verbatim out of the book, but yeah, as a group, that's a good question, right? I guess, because have you had the practice of doing the problems on your own if you're working in a group? It's kind of like in an instrumental. If you're the dude standing there not pushing the buttons,
Yeah.
that's very different than the dude sitting there pushing the buttons.
No,
Yeah.
I think for this group, I think we've all been doing a lot of stuff on our own. So I do believe we have a
So
lot
you-
more practice.
You should be, just get ready, just be used to and be 100% comfortable with the terminology, right? Normalize this. You know exactly what to do, right? Is this normalized? You know what to do. What's the probability, right? And then eigenvalues, eigenfunctions. Just be used to the terminology, because the math you've had a lot of practice on.
so I'm just going to throw this out there, because we're really well treated at UAW. But are we going to get test corrections?
No.
But then again, we do have an exam.
But see, my exams are very different.
Yeah.
My exams are, I test you on what you do in the classroom. So therefore, I'm much less, in fact, I don't even have a curve. You know exactly where you are in this class. Because, well, plus minus a little bit, because we dropped some stuff. But by 90, 80, 70, you know exactly where, everyone in here could get an A. That's not possible where they curve. It's just not possible. Yeah, but even there, on a bell curve, only one or two of them, the top, are going to get an A.
Did you get the same answer?
I went to grad school with a guy who taught the stuff that we were in the class on. That's just not fair.
On the second step, did you pull off the 1/2 all the way to the front? So it's 1 over L?
This is like
Yeah.
So 2 over L?
Yeah, it should be 1 over L.
Okay, that's what I did too.
Yeah.
So I
You don't
was-
have to leave it in there. You can
Yeah,
bring it
yeah,
all
because
the way.
that's then I do get something different from that L over 4 pi then.
Oh, really?
Now notice how, if you remember that unit circle, your life, it goes a lot faster, right? Because you, like the sine of b is 10, you just end up with the sine of 2 pi. Here you end up with the sine of 0. So if you know that unit circle, you can just put in zeros
Yeah. Yeah. That's just,
instead of worrying about calculators and oh my god, right? So much easier.
That's the other thing. You said those are going to turn into zeros, right?
Yeah, because the sine of, remember the unit circle? The sine of 2 pi and 0 is 0.
That was my question, because we had run into a problem, and I had told Pablo, that's how you get rid of it and make it just this or whatever. But then I thought about it, and I was like, who's to say that B or A isn't like some, what makes it not a number from zero
I
to
told you what B
like-
is.
what
B
is it?
and A are the definitions of your limits. It's found between B and it's found between A. So you have to give you two numbers for B and A.
Uh-huh.
Otherwise, the whole thing doesn't make sense.
And you're saying that they turn into zero, right? Because-
No, the they is this.
Uh-huh. Those, right?
Yeah.
Because then I thought about it, and I was like, who's to say that B or A isn't something like...
It's not always gonna, but you're right. It's not.
You know what I mean?
When I bet you the next question is gonna be meaner. They're not gonna have these signs go to 0. You can get some numbers here. Hopefully, otherwise, what's the point of doing all this homework?
So we just assume that B or A is like a whole number?
No, there's no assumption. No assuming. they have to tell you what B and A are. In this first part, what is B? B is B. What is A? A is A. Right? You just have to put something in for it. And the next part, they tell you exactly what A and B are. And the last part, part D, again, they have to exact. And look, there's no way you're doing some calculating here on part
like
D. That's a good one.
That's not going to turn into 0.
You're going to have to actually use the calculator. And make sure the sign is in what format? Radians. It'll work.
Now, why is it in radians again? Just 'cause
I think, well, it's in radians. I say pretty much because you're dealing with decimal numeric values. You're dealing with lengths, really arc lengths. They're not, you know, a piece of a pie like 10 degrees, 15 degrees. It's not that. You're dealing with the length out here, and that's a decimal value. And
yeah, we haven't really seen any degrees.
you can see any. Yeah, no, you're not.
I see.
So see if you can get these. See if you can get D. Now, if you go through all this work and you get a number for D between 0.405 nanometers and 0.505 nanometers, what's the probability the box is 10 nanometers? Which, if you're just going to guess, what would you guess? As the probability as your answer. What would you guess?
And which one?
In this part D, what would you just guess as your answer?
Oh, I would guess it'd be
1
1.
means 100%.
10. 0.1.
Right? This is what's going through my brain. 10, 0. Between 0.405 and 0.505,
Move it to the left.
what's the probability of it being in here?
Yeah.
See that length? 0.405 and 0.505.
Yeah.
The probability is going to be, guess, it would be,
5 times 0.01.
that's 1%.
1.
0.01 is 1%.
Yeah, I would say 0.01. Because usually with C, what you did is you take from 0 to 10, which is 10, times 10. That's 100, and then you move it 2 to the left. So if you do the same thing with D, you get from 0.4 to 0.5, just ignore the 5, you get 0.1 times 10, and that gives you a tenth of 10, which is 1, and then you move that 2 to the left. And that's 0.1.
Yeah, so just thinking of that, it's just it should be a really small number, right? I would say a tenth might be a little high. That's 0.405, 0.505, and it could be. Realize it could be extremely low if that's a node, right? So we don't really know where that standing wave is because we're not plotting them out.
It's like 1%.
But it's got to be a dinky number. That's what I'm driving at. Okay. So come by as early as, and I'll probably even as early as 7:30, if not earlier. I'll be here on Wednesday. And just get used to setting these up, and I think you'll do fine.
Keep your cold thoughts.
Huh?
Keep your cold thoughts.
Yeah. This is Texas, though. What are the odds of it happening twice?
Downtown.